Good morning, one and all. Dear students, I welcome for this parallel programming lab session where we will be discussing primarily two methods how to process or how to build a program related to parallel task. For an example, there are two methods primarily employed. One is OMP and the one is MPI. So in today's session we will see one example related to hello world. So what you have carried on a basic C program and comparatively in what is the difference you can see in OMP programming method. So here you can see the hello world program where we start with hash include std.h, which includes all the standard library where printf, scanf will be there, and next header file will be omp.h. so this includes all the OMP parallel directives and runtime compilers and environmental variables. So then we start int main function, and there is one compiler directive that you need to include in order to do any of the parallel tasking is hash pragma. So this is a compiler directive where it will support parallel processing. So here you can see hash pragma OMP parallel, where whatever this portion of code that is written within this flower bracket will be executed in parallel modes. So for an example, here we are printing hello from thread %d\n, and we are getting a thread number. So this is called a runtime directive which will be supported by MPI, which will be supported by OMP during the runtime processing. So here OMP get thread number is, for an example, if your system is having around 16 thread, so you can able to get hello from all 16 in any order. It need not to be in sequential or anything. So we can able to go through once we compile and run this in basic gedit. Okay, so it supports C, C++, Fortran, but conventionally we follow a simple C program and we add OMP header file in order to do this hello world program in parallel mode. Okay, so after placing the flower bracket we will return. So to compile we need to type gcc space dash f openmp, hello.c is the file name you need to give, and dash o indicates you need to create an output file name with hello. So why we need to create, because since you do multiple programming, better you create an output file name with the same file so that you can access at any instant. To verify the output you just type dot /hello. Okay, so now we will be switching on to the CMD to run this simple program. Okay, so now we are switched on to this CMD. So the one thing is let us type ls so that we will see what are the files and folders that is available, and better you create one folder with your name. Okay, so that all the files will be available in the same. Okay, now we have created a folder with faculty as a name. So let me change the directive to the faculty. So now I had moved to that directive. So here no file exists. So now you can go for a simple file, that is hello file, how to create. So you can just type gedit. Let me give the file name as hello.c. So an editor will open. So in this editor we will be writing the same code which was explained. Okay, so the same the set of code what we are explained previously, the same thing it has been written. So here primarily what you need to understand is as pragma OMP parallel, it will do this task which is printing allow from thread, and how many threads, so that also will be cleared once we run this code after compiling. Okay, so this is a runtime directive where OMP underscore get underscore thread underscore number, so where so the thread number will be generated randomly by the process based on its availability, and it will be printed. Then close the program by writing return. So let me save the file and close. So here you need to type gcc space -f open mp space hello.c, that is the file name, space -o to create hello with the output. So if you type, so the compilation has been completed, so no errors has been detected. If I just type ls, you can observe that the output file name has been generated, it is hello. Okay, so to run the file, so just type /hello, and here you can specify the number of threads, how many threads you require. So if I specify 4 means, so the 4 threads will be printed. If I want specify 4 means, you will be getting all. Let me not specify the value. So here you can see around from 0 to 15 the thread has been printed. That is the same message, that is hello from thread 0. And let me make it clear. So the output can be received from any of the thread, it need not to be in sequential order. So here you can see, if I run the same thing hello with only 4, so but for this I need to export. So here you can see maximum 15, here you can see the alteration in the threads. Okay, so this is a simple program wherein we had shown how the hello world program can be executed by multiple threads. So once again, thank you.